Okay, ladies and gentlemen, welcome to 7.3. We're going to go through the warm-up here first, which is the bell ringer. Right? Write the expression in simplest form. Probably the most simple way to do this would be to rewrite your numbers with straight up exponents. Get rid of those cube roots. So you're looking at 7 to the 1/3 times 7 squared to the 1/3. 7 squared is 49. I can now add across my exponents. This would be 7 to the third power, all raised to the 1/3. This would be 7 to the 3/3, which is just 7. Okay. More than one way to do that. You could always multiply 7 times 49, which is 343. Okay. You can also do this. So that's 343, another cube rooted out of 7. Okay. However, I don't have a calculator up right now, so I did it in a way that would require a calculator. As far as the next guy goes here, these are powers of 2, so I can rewrite 8 as 2 to the 3rd. This is still being raised to the 1/3. 512. How will I do, let's see here. 2 to the what? Well, that's going to be rather large. In fact, 2 to the 9th is what 512 would be. We would have 2 to the 9th. So when we actually do this, because it's division, I'm going to subtract those exponents. So this would actually be 2 to the 6th raised to the 1/3, which is then going to be 2 to the 6th over 3, which we all know is 2 squared. Okay. You could also do this a little bit differently, right? You could also jump from this step and say, oh, well, I got 9 to the 1/3, okay? And that would be basically 2 to the 3rd. On the bottom, we would have 2 to the 1st. And again, you can see that you'll get here to 2 squared. Always more than one way to do these. You're more than welcome to go either way to get to the final answer. Now let's walk through some of our rules here. We're dealing with basically functions, and we're going to substitute in 2x, which is here, for our f of x. We also will substitute in our x plus 1 and for g of x. And we're just going to combine like terms and add these. So, while the total of 3x's plus 1, that's what h of x would equal when we do f of x plus g of x. Subtraction, same idea, substitute in 2 of x for f of x, g of x is here, x plus 1. So basically we need to distribute this negative in both. So 2x minus x is 1x minus 1. Okay? Multiplication, substitute in, this would be a distributive property. So we're looking at 2x squared plus 2x. Nothing really new here, you just are actually substituting in and doing the operation until it's telling you to perform. So again, f of x is 2 of x, g of x we'll put in x plus 1. Okay. I can't factor that at all. That is actually the final solution. Okay. So, okay, as far as the question at the bottom of domains goes, the domains will consist of whatever the domains of both f of x and g of x are. Okay. Additionally, the domain of the quotient does not include x values for which that g of x would equal 0. Primarily because, well, we can't divide by 0. So in this case, okay, x cannot equal negative 1. Okay, so your domain would be for g of x, all real numbers except for when x is negative. Okay? Moving right along. Okay, I'm going to pick the pace up here. I'm going to substitute in for f of x, the 3x squared, plus e of x, which is negative 7x squared. So really, this is just negative 4x squared. You can call it a day. Combine like again, f of x is 3x squared. This time we're going to subtract g of x, which is negative 7x squared. Two negatives we know make a plus, as old Mr. Baldino would do. We write it like that, leaving us with 10x squared. Okay. Then f of x minus f of x. Usually, anytime you subtract something from itself, it's going to be 0. Okay, so there's the completion of your first page. see a soon here. Okay, so continuing what we were just working on, we are going to substitute in 5x to the 1/2. For some reason I wrote 3, 1/2, plus a negative 4x to the 1/2. You can think of this as basically the square root of x bottom 1 plus a negative 4 square root of x. This is basically 1 square root of x, or 1x to the 1/2. Either one of those would be fine. So going with the same idea here, this time we're going to actually be subtracting that negative 4x to the 1/2. So basically this becomes plus, and we're looking at 9x to the 1/2. Then the last one, we have g of x plus g of x. Dealing with that sun that showed in. So if we actually go through this, this would be negative 8x to the 1. And we can add those because the bases and the exponents are the same, they match up. So we can actually do that addition. And the exponents do stay the same. Alright? So shift down here. We're starting to get into compositions here. We're going to do f of x times g of x. Do your substitution like normal. Okay? Slow and steady wins the race here. Think about what we have going on with when we multiply. We can multiply the numbers out in front. We can do 2 times 6, which would give us 12. And then we have to add these exponents. So we have to do 1/4 plus 4/5. Definitely going to need a common denominator. A common denominator would be 20. So if both of these have a denominator of 20, I multiply 4 times 5 to get 20. So this is 5 times 1. I multiply 4 times this 5 to get 20. 4 times 4 is 16. I now have to do this addition problem as my exponents. This is 12x to the 21 over 20. That does not reduce. That's what we do. Okay. Moving to number 2, with the g of x's, we would have 6x to the 4/5 times 6x to the 4/5. And we're going to go through the same properties as before. We're going to multiply these numbers out in front to get 36. 4/5 times 4/5, well, that's actually an addition problem because of the exponent, so that would be 8 over 5. Okay, and that would be where we stop. Going with number 3 here, f of x over g of x, so we have 2x to the 1/4 over 6x to the 4/5. We can reduce 2 over 6 like we normally would. That's going to be 1/3, but as far as the exponents go, and this is going to be a little more challenging. Now remember what we do here. We subtract these exponents. The larger one wins out. 4/5 is larger than 1/4 because this is 0.8. This is 0.25. So we're going to end up with a subtraction problem at the bottom. So we got 4/5 minus 1/4. Good news is we've already got that common denominator from before here of 20. So this is going to be 20 again. Multiplied by 4, so this is 16. And this one would be 5 times that. So really when we're all said and done here, this is 1 over 3x to the 11 over 20. And that's pretty good stuff. Okay. And then we're going to finish up here in a second. This next part is usually the most confusing for people. What I'm going to do is I'm going to basically substitute the inside out. So I'm going to put 3x squared or 3x to the 5th in for g of x. And now I'm going to write f. But instead of x, I will leave a big blank there. So every time I see x here, I'll leave a big blank. I can put in 3x to the 5th. That is where g of x is. So now I just have to evaluate. So this is going to be 3 to the 4, x to the 20. Okay, multiply under exponent. So 3 to the 4th would be 3 times 3 times 3 times 3, which is 9 times 9. So this is 81. X to the 20th. This is being multiplied by 2. So we can stop at 162 x to the 20th. Okay. So let's jump to 2 here with g of f of x. So g of x stays. I'm going to put 2x to the 4th in for f of x. So that's this. Now I'm going to rewrite g of x. This is 3 blank to the 5th. I put in my 2x to the 4th here. And I go through basically the order of operations. 2 to the 5th, x to the 20th. Okay. 2 to the 5th is 32, so this is basically get basically 96 x. Again, dealing with that sum issue, I hope I didn't mistransfer anything. Jumping down here, the 3 f of x. So I'm going to put in 2x to the fourth for that inside guy. And then I'm going to write 2 blank to the fourth. I'm going to put that 2x to the fourth in there. That's where this x used to be. 2x to the fourth. So I'm going to have 2 times 2 to the fourth, x to the 16th. This is 2 times basically 16 times x to the 16th. We know that that would be 32 x to the 16th. Finished. Okay. Going with the g of x. So this is g of the x to the fifth. So when I rewrite this again, I need a blank where the x is. I substituted my 3x to the fifth. So this is 3 times 3 to the fifth, x to the 25th. 3 to the fifth would be 243. We know 3 to the fourth is, what was it? Just did it here. It's 81. Okay? So if I do 81 times 3, I'm at 243. And then this is x to the 25th. Multiplied by 3. Go ahead and get 729 x to the 25th. Okay? Now I do have to hustle here at the end, because I only have a couple minutes left of recording left. So to get this all in one film, I'm going to get moving through here pretty quickly. Okay, do your straight substitution, my left terms. Okay, straight up substitution here. Notice I'm using parentheses to subtract all of g of x. This is 3x plus 9. Shift it down to f of x times g of x. And this is a distributive property problem. So I get 10x squared minus 45x. And to finish up here with f of x, which is 5x divided by 2x minus 9. There's no factor I can match up there on top and bottom, so that's what you would stop with. 5x over 2x minus 9. Okay, continuing along here, you can see I put it up here for 5x over 2x minus 9, so we can still reference it. And again, do f of x. I'm going to plug in 2x minus 9 in for the g, and I can put 1 in for the x. Okay, I can put 3 in here. So what I'm going to do is I'm going to do 3 times 3 minus 9. I'm going to evaluate that. That's 6 minus 9. So I'm testing f of negative 3. When I do that, I'm going to put negative 3 into this guy. So this is 5 times negative 3. You all know that's negative 15. So if I'm doing f of g of 3, we're looking at negative 15 as your solution. And g of x. Let's go to the next guy. So we have g, I'm going to put 5x in for f of x. Now I'm going to write g of x. So this time I'm going to leave a blank for the x's. I'm going to put in 5x there. This is 10x minus 9. No like terms to define. Going down to f of x. Let's do f of x. Sounds really ridiculous. Doing f of 5x, which means I'm doing 5x. Okay, 5 of 5x. So when we finish doing this guy here, we're looking at 25x. Basically substituting in 5x into here for that x. So we're doing g of negative 4. Finish up here. Let's start with g of negative 4. So this is 2x minus 9. I'm putting in negative 4 there. So I'm going to have 2 times negative 4 minus 9. So we're doing negative 8 minus 9. So we're doing g of negative 17. Which would look like 2 times negative 17 minus 9. Of course, parenthesis there. So 2 times negative 17 is negative 34. We subtract 9 from that, we're looking at negative 4. So, that would be g of negative 4. Right. If you guys have questions, send an email to me and let me know what's going on. Just made it under 15 minutes. Good luck. May the force be with you.